My name is Cavello.
I'm Susannah Shattuck.
We work at IBM, actually just a few doors down at Watson West, which is where we meet with clients every day to help them strategize how they're going to apply AI to their businesses and their lives. So what we wanted to do, we talked to a couple of you beforehand. We know some of you have a data science background. There may be a little bit of a diverse group here today. So what we wanted to do is really talk to you about how we bring up these topics of AI and different types of data and conversations and make it relevant to business decision makers.
Yeah, business is already being completely transformed by AI. I think we all know that. That's why we're here in this room. So our job on a day-to-day basis and what we want to have a conversation with you about today is how can we empower business decision makers to really deeply understand the technology and its capabilities and then apply it in a smart way that's actually going to hopefully improve the world and make all of our lives better, as opposed to, you know, the dystopian future where we're all slaves to some robot overlord. So we want to have an open dialogue with you. Please feel free to raise your hands and ask questions throughout the presentation. We're going to have a couple of interactive activities during the presentation.
Right, the first of which is actually one that we do with a lot of our clients as they come to start out these discussions. So oftentimes people come to us, especially given all of the buzz in this space coming off of the back end of big data, and now we've got this whole AI trend. People have a lot of ideas about what these things mean. There are a lot of maybe unfamiliar terms. And one of the first activities that we like to do is actually something that comes out of our IBM design thinking practice, which is an activity called hopes and fears. So as you can imagine, it involves expressing your hopes and your fears. And so what we've actually done, the first interaction that you will have is you will see on these tables in front of you, you do have a series of Post-its. Feel free to break them apart into some more sets so that each person can write. And what we want to do is give you the opportunity to write down what your hopes and fears about AI are. And these could be things like, I'm optimistic about getting a job, I just finished school, I'm looking forward to participating in this exciting field. It could be, I'm freaked out about Skynet. And we'll start it off, we'll start a timer and we'll just say some of ours, but if you'll take a moment to write down, I'll give you a minute and a half just to write down what some of those are for you. And if you'll write the fears on pink or warm colors and your hopes on blue colors, that would be awesome. And then we will smack them up onto this whiteboard here. You will be semi-anonymous unless you have really, really distinct handwriting.
Yeah.
So I'm going to start this timer. Susanna, do you want to share one of yours?
I'll give you an example. So my hope for the future that is shaped by prolific AI is that we as humans will be enabled to focus on the most interesting and valuable problems, and all of the busy work, all of the extra stuff that we don't want to do in the day-to-day will be taken care of by automation and by intelligent systems. My fear is that in this future there will be no such thing as independent individual privacy and autonomy, and that everybody will know everything about each other because all of our private data is being uploaded into a single cloud that everybody has access to, including corporations.
Yay. All right, so with that as your preset, if you'll just take a minute and a half here to write down on the blue your hopes, on the pink warm color your fears, and we'll give a moment to reflect on that.
So, as we're putting these up, I can start to read some of them and we can get a sense of how we're doing. Yeah. So we have a lot of hopes around, let's see, using it for good in the world, improving the day-to-day quality of life. Ooh, interesting. Hope that decision makers will be able to anticipate and prevent problems they face. AI will make life easier. Better sanitation in highly populated cities in the developing world.
We also see questions about accountability, maybe some optimism that as we use data to track things, we will drop Post-its on the ground. We will have maybe a little bit better sense of who's responsible for what in the world. But people are also very concerned about privacy. There's this concern about employment, of course. Not knowing, some folks are not sure where they fit into the picture. How do I get involved with this? People also wondering about how we can actually use this power wisely, avoiding Skynet and political instability. And also that there's fear around what the impact will be on our regulation. So we're going to continue to add those up. And why we do this framing exercise at the beginning of these conversations is because, one, it's really helpful to know where people are coming from. People step into these meetings with us oftentimes with very different ideas. And so one of the practices in design thinking is this idea of getting alignment so that you can diverge and converge creatively. So what we're doing here is we find an alignment amongst people. We see some very clear trends. We also see some folks wondering where they fit into the picture. So one of the things that I think is a really valuable skill when you are approaching these topics, especially if you're coming from the data science side, is understanding how it is that your business colleagues are actually thinking about the stuff that you're doing. So before we get too much into that, I do want to kind of step back and look at where we are and where we're coming from, right? Work isn't always great. In fact, oftentimes it's really inefficient and poopy and lame. And the reason for this is because even though we've been doing business for thousands of years, a lot of our practices for doing business are set a little bit in the past. We've developed different processes for working together, but unfortunately that information has only accumulated over time, and so we've ended up with this situation where there's all of this data that we have available to us, but a lot of it exists in these very old-fashioned formats. In fact, it's very common, especially in industries that are very kind of close to the earth, if we're talking about resource extraction and construction, to actually have very many physical paper documents. So when we look at this world, we see overall this trend of digitalization, right? People are digitizing their documents and moving toward a space where there's more information that can be easily queried. Hopefully we're getting access to that. So when you all are talking about your work, a lot of you are data scientists, how many of you work with, let's ask, how many of you work with what you would call structured data? So think a lot of numbers, a lot of things that are in spreadsheets. Maybe you're looking at JSON returns, maybe you're looking at IoT sensor outputs. I'm seeing some shaking heads. So that type of information has really exploded. That's kind of what the whole big data craze was about, right? We have all of this information, we're moving it into this space where we have it available to us, and now we can do fancy things like make pretty data visualizations and charts and hopefully cool dashboards, and that's probably where a lot of us live. Now, the problem in this framework is that a lot of that data that we've collected has had some additional context that's missing. So what we call this in the industry is dark data, right? There's all of this additional information that surrounds this data that we've been collecting off of our sensors and all these things, but ultimately a lot of it previously has been pretty much invisible to most people. There are two reasons for this. One is that it oftentimes exists behind a firewall, so you have to work within your organization to get permissions to access this information. But additionally, it comes in a format that historically has not been particularly machine readable, right? The types of contextual information that we're talking about here are things like documents that are written, notes that are written, right? We've all been in the spreadsheet, we've seen that danger zone category. In fact, I think this is a helpful point to talk about this idea. So most of us who are working in the data space are familiar with seeing something like this, right? We got our, whatever, number of units, the data, the set time, temperature data, all kinds of cool stuff that might be coming off of your IoT. And that's all fine and good. That is information that we're used to working with. Most of us who have experience in the data science space feel pretty comfortable. But there's another side to this, and that is the danger zone in your spreadsheet, right? This is the comments, the notes. And this information is where everything starts to break down. Like you've got all this beautiful temperature data, and then somebody went in there in the notes section and wrote, actually, the temperature gauge is broken. So that data's not reliable, right? And I've actually had clients in discussions who are brought to this epiphany moment. Because, right, coming back to this idea that work isn't always pretty, there's this problem that exists in this space where we do all of this beautiful modeling, all of this incredible work that we do, and then somebody realizes something has gone wrong, there's something that is amiss. And then we have to spend all of this human labor, all of this time combing through those spreadsheets, trying to find where somebody has taken that now. right? And so when we're talking about this information, this kind of represents to me the divide between structured and unstructured data. And I feel like this diagram in particular is really, really helpful when you're working with business folks. So when you're trying to communicate the stuff that you're doing, get out your whiteboard marker, draw you some lines, right? Draw a spreadsheet and say, are we talking about this stuff over here? Or is that data actually existing on this side of our spreadsheet? You know, our metaphorical spreadsheet here. And when we talk about this, of course, we're not just talking about spreadsheets. And the kinds of unstructured information can actually vary quite a bit. Anything that would screw up your Excel are basically unstructured data, right? So if you've got sound files, if you have written comments, if you have imagery, all of that information exists as unstructured data. And that's the kind of information that we today are going to primarily focus on. So when we talk about AI and how it's impacting the business and frankly, political landscapes today, we're talking about a combination of these things. It's not one, it's not the other. You don't just want to know the temperature sensor is broken, you do. But you also want to know that temperature data, right? Both of these are incredibly important. But what we're going to focus on as we're talking through how we approach these conversations with clients is particularly how this unstructured data is changing the way that they're going to have to go about their business. So coming back to this idea, people acknowledge that there's a lot of unstructured data, and we've all probably encountered this. This is actually just an image search result for terrible porn, right? And so you see there's all kinds of information. They're asking, like, what is your experience with studying language at school, all this different stuff. And all of that information is people trying to make themselves fit into this idea of what the computer wants. Right, so we take our unstructured lives, our unstructured reality, and we try to fit it into this formulaic perspective. And it really doesn't work. There's a client I was working with, an airline, and they're in the airline industry, as you can imagine, turnaround time is incredibly important. When a plane comes in, they got to deplane people, check everything, make it safe to fly, make it clean, get that thing back up in the air, right? And what they had is this brilliant idea. We're going to get a mobile device that our technicians can use when they're performing the check on the plane, and they'll be able to enter all of this data in about what's going on, and we'll be able to know what's happening so that we can maybe have some preventative maintenance and so on. Great, great idea, very optimistic hope. And what they created was something a little like this, right? And what they found as they were looking at their data is that there were a couple of issues that the technicians were reporting at an incredibly high volume. Right? People just, all of these planes are having these 3 issues all the time. And they're like, dang, we're screwed up here. But when they went back and looked at the way that people are inputting that data, coming back to our design thinking and person-first perspective, they opened up the mobile app and they realized, oh, we created a drop-down menu with a bajillion items in it. And people don't scroll through a drop-down menu, they just pick something that first pops up on the screen. So all of those issues that are being reported, the technician's like, yeah, you know, I guess it could count as one of those, and they would just send it in. This is the problem with trying to take our unstructured lives and fit them into structured formats, right? All of this information ends up building up, and we aren't able to process it in a strategic way. So instead, what they ended up doing is incorporating unstructured data, which meant the technician actually writing in notes. Frankly, notes in jargon that I would not be familiar with at all, because technicians speak their own language, right? So we created the system to be able to pull out knowledge, extract meaning from these notes. And in some cases, they actually do it with audio input as well. In the airline industry, sound issues kind of made that not applicable for this particular client. But we have these applications where we can, instead of trying to fit our technology around these messy human experiences, actually make the technology fluid in the way that we approach this information. So when we talk about this stuff, I think it's helpful to think about how do we think about unstructured information and what are the ways of approaching it. So you probably, if you know anything about IBM Watson, you've probably seen like a little talking iPad, and you've probably heard about us competing on Jeopardy. Right, so Jeopardy, back in 2011, it was a big deal. If you didn't see the episode, spoiler alert, we won. It was awesome. And what we did is we built out a system that was good at answering questions in natural language. Or in this case, it was actually questioning answers because of the rules of Jeopardy. But what we had to do was think about how could we build out a system that's really, really good at playing the game Jeopardy. We did that. It was awesome. If you actually go back and watch that episode, you'll see like IBM researchers scurrying around in the background because that wasn't a real Jeopardy set. Watson was such a big monolithic thing at the time, we had to bring Jeopardy to us. We made a replica set of Jeopardy at our research headquarters up in upstate New York because that was the only way that we could access the massive amount of information that we needed at the time. Now, that was cool. It worked. But the problem with that situation is that, one, it doesn't scale, and two, for most applications, for most people in their day-to-day lives, being really, really good at playing Jeopardy isn't actually what they need. So what we had to do was instead turn that system into something that could be more useful for a variety of applications. And we broke it up into these variety of categories. So we're going to talk about some of these. We're going to talk about this application of empathy, understanding human insights, understanding, of course, speech analysis and language, but also talk a little bit about how we incorporate this into knowledge management and incorporate it even with structured data. So what we'll do is talk you through some of the different workflows that we approach this conversation with our clients. So what we do is we actually turn this conversation not into a conversation about technology, but a conversation about what problems people are trying to solve. So as you think about this dichotomy between the structured and the unstructured, we're going to take you through a couple of examples of places in which we've used this information, and then we'll revisit this idea, this alignment, this context setting, and open it up for an opportunity to talk about what this means for us. So with that, I'm going to turn it over to Susannah.
Awesome. Thank you, Bea. That, I think, was the perfect setup for talking about how we're actually applying this technology in business today. So as Bea mentioned, what the goal of the AI that we're talking about when we say Watson is to really help marry that unstructured and structured data to solve real business problems. And this slide you see here is an encapsulation of the way we're thinking about the different types of business problems that we can solve with Watson technology. So we've broken it down into what we call 6 different workflows. And if you work in any part of your business that touches on any one of these workflows, spoiler alert, your life at work is going to be completely transformed over the coming years because we are building AI systems, and it's not just IBM, right? It's every player in the AI marketplace is building AI systems that can help people do these things more effectively. So I'm going to go through each one of these 6 workflows and talk a little bit about what we actually mean by it, like what does that mean in the business world, and then also give you some examples in the form of technology demos, client use case stories with KPIs and numbers that we can share so that you can really get a sense of what's actually happening today. I noticed that one of the fears that somebody wrote up here is that AI is a buzzword that doesn't actually mean anything at the moment. So hopefully this portion of the presentation will help us all understand what's real today and ultimately what's also coming down the pipe. And again, I really like it when presentations are interactive, so please feel free to stop me and ask questions at any point. So I want to start by talking about actually my favorite workflow, accelerate research and discovery. This is a huge area of focus for AI. In many ways, this is one of the areas that AI is being applied most successfully today. We have this power with the analysis of unstructured data that AI systems give us to make it a lot easier for human researchers, human scientists, to navigate the huge volumes of data that are being produced daily, weekly, yearly, to better understand how to find the exact information they need, right? To find that needle in the haystack that is the act of research and discovery. So some quick stats around that huge volume of data. 90% of the data in the world today was created in the last 2 years. And there are 2.5 million English language peer-reviewed scientific papers that are published each year. I, as a doctor or a scientist working in this field, would have to literally spend 24 hours a day, 365 days a year, just reading articles to manage to read a tiny fraction of that information. So I, as a researcher, am faced with this huge problem that there's much more information being published in my fields than I have the ability to keep up with. So one of the ways that we're applying Watson technology to solve this problem, we have a tool called Watson for Drug Discovery, which leverages some of our natural language processing capabilities to help pharmaceutical researchers better navigate the available information in both published and unpublished proprietary data peer-reviewed articles, Medline abstracts, but also data that their own company is producing to really quickly identify new paths for drug research. So an example, the Barrow Neurological Institute used this tool. They were one of our primary partners as we launched this tool. And they are focused on identifying proteins that are related to ALS. Because if you can identify the proteins that are involved in a disease, it's a lot easier to develop drugs that actually target the way that protein behaves in the body than to go in and try to modify the genes that have caused the disease in the first place. So to develop ALS drugs, they were looking to discover these proteins. And normally it took years to find a single protein. This was a very labor-intensive project that required many researchers working for very long periods of time. They started using drug discovery, and they were able to identify, with the help of this tool, 5 new proteins related to ALS in a matter of months. This dramatically shortened their research process because they were really quickly able to go navigate all of these articles that they never would have had time to read in full. And beyond that, the Watson for Drug Discovery system is also able to find relationships within those articles that might not be so obvious to a human researcher. A human researcher can't remember everything. Do you remember everything that you read in the last day, let alone the last 3 years? An AI system doesn't forget what it's read. So the ability to find those connections, particularly secondary or even tertiary connections between genes, drugs, and diseases, is something that's really powerful in this tool. Now, something that I'm going to be emphasizing throughout this portion of the presentation, we aren't creating an AI system here that is going out and doing all of the research and writing a paper on its own, right? This is a system that's designed to be what we call an insight delivery system, an insight generating system that allows humans to have the information they need to make the best decisions. Where the technology's at today, we're pretty good at creating these insight delivery systems. That's not to say that down the road, we aren't going to have the technological capabilities to create systems that can write their own research papers, that can do everything from front to back. Yes, question?
In this case, do they just highlight useful or potentially useful papers, or do they do more than that?
So it's a combination of things. We do have, one of the screens in the application has this query section where you can say, show me all of the relevant information to this gene, and it will surface relevant papers, but it will also create a biological entity network map. So you see the relationship of that gene to other genes, drugs, diseases, other entities within the research field, so that you can actually go and sort of navigate not only papers relevant to that one gene you're looking at, but relevant to drugs that target that gene. And then through that, that's how you find the tertiary, the secondary relationships. Yeah. Cool. So again, creating these insight delivery systems to help humans more quickly and effectively make research decisions. This is where we're at today. So if any of you work in the research fields, there's a lot of fascinating work to be done in leveraging AI to help you do that faster. All right, if there aren't any more questions about this particular example, I'm going to move on to our next workflow, recommend with confidence. How many of you have used Amazon in the last day? Oh, wow, not a lot of you. Okay, cool. Well, I have. I just moved, so I've been using Amazon pretty much every hour to buy all of the things that I'm now realizing I need in my new apartment. And if you've used Amazon in the past, you probably have gotten the recommendation, people who purchase this product also tend to like to purchase these products. That's a great example of a machine learning algorithm that does a really good job of recommending with confidence things that it thinks you want to buy. Now, that is one example of the different ways that we're leveraging unstructured data and also structured data, right, to better understand people and ultimately make decisions for the next best action they can take. So a couple of factoids to prove that this is a critical area of focus. 67% of consumers will grant banks access to more personal data, but as a result, 63% want more tailored advice. So people are more willing to give companies their data, but they're expecting something in return, right? They're expecting a more personal experience. And experts are predicting a 4,300% increase in annual data production by 2020. So there's plenty of information out there for all of us to leverage to better understand the people that we're interacting with, the systems that we're interacting with. So how can we take all of that data and use that to construct a better model of what the next best thing we should do is. Whether that's recommending a product to a potential customer or recommending the action that a technician should take as a technician is working to repair a piece of equipment in the field. Lots of different examples. The example that I'm going to give you today is one that I hope we can all relate to, doing your taxes, right? Doing taxes is a mandatory, terrible, torturous exercise. And H&R Block is a company that focuses on helping people do their taxes more effectively, getting more in return, not having to pay as much money to the government, all kinds of good things. Now, here's the problem. The US tax code is incredibly complex. This is just the federal tax code alone, 74,000 pages. That's the equivalent of reading War and Peace about 600 times. So you can imagine that a human expert on the tax code, they probably forget some of those 74,000 pages, right? They're only human. So H&R Block came to IBM and they said, we want your help creating a system that can help our human tax experts make better recommendations to our customers for how to save money, how to do their taxes more effectively. So we created a system that we called the cognitive interview system, which was an AI system designed to analyze an interview between a human tax expert and a customer and make recommendations to that tax expert, that H&R Block employee, of the questions that they should ask the customer in the store to better understand potential tax return opportunities. So we created a system that could analyze those 74,000 pages of tax code, but we also created a system that needed to understand the human interactions that resulted in data being generated that helps us figure out places in the tax code where we can save money, where we can get a better tax return. So it was a combination of analyzing the unstructured data of the actual regulations, the actual code, and analyzing historical conversations that tax experts had had with H&R Block customers, and mapping those to outcomes. And when we were able to analyze those two things in concert, we now have a system that can pretty accurately recommend to a tax assessor, to an H&R Block employee, you should ask this person if they've worked in 3 different states over the last 5 years. It seems from their work history like they're a freelancer. There are lots of complex rules around wages earned in different states. You should ask this person that question. Or you should ask this person if their child has had violin lessons, because that actually could be tax deductible under their current tax status. All kinds of interesting things that the human might not think to ask, but the AI system can recommend based on what it knows both about the regulations and about historical tax conversations. So any questions about this?
Yeah. Do you know how much money you would save?
Oh man, I wish we did. H&R Block is interesting in that they've shared with us that they thought this project was really successful, but they use this internal points system that nobody can understand outside of H&R Block. So they're like, we improved customer retention by 2 points.
But it doesn't, that's what I mean.
So yeah, we have some case studies and stuff that I can make sure that we send out to the group afterwards that have some of that data, but we don't have dollar figures, unfortunately. Any other questions? Yeah.
Is it a product that, the clients outside HR will use, or you should get clients, or what's the...
Really good question.
Users?
So I think that drives at a slightly larger question of like, what's the business model for these kinds of interactions? I like to think of the business model for the way that IBM interacts in the AI marketplace, but generally this is true with other major companies as well, as a sliding scale, where we have everything from the DIY API that you pay fractions of a cent per API call to do an analysis of an image or an analysis of a piece of text and get back JSON that you can use in whatever application you've built yourself. And then at the other end, we have a highly custom, IBM builds it for you and probably also provides consulting services, and it's a whole big, potentially years-long project that's more in the millions of dollar scale. Then in the middle, we have these SaaS applications like Watson for Drug Discovery that I just talked about, that we created with a partner to train it on that subject matter and to make sure that the system works on the data, but then anybody can use, as an individual user, you pay per month. And that's more in the thousands of dollars range. So this H&R Block solution is not something that we created in partnership so that anybody can go out and use it. It's more of a custom application that we built for H&R Block.
So they had to provide a data set, right?
Yeah, so they provided the historical tax conversation data set. And that gets into a really important point, which is the number one thing that you need to make these systems work, as we all know, is data, right? You need to have data that reflects the type of information that you're ultimately going to be trying to analyze, that you're ultimately going to try to understand. So whenever we work with a client to bring a solution to market, that's the first thing that we have to ask and that we have to talk to them about. And that's one of the huge reasons why IBM partners with a lot of companies to build solutions that then we go to market together, because we recognize that while we're the experts in this technology, we're not the experts at pharmaceutical research, we're not the experts at curing cancer, we're not the experts in lots of different things that we're trying to build solutions to solve for. So we work with partners to find that right data set and make sure that the models are trained correctly with that subject matter expertise.
So, question, why Watson instead of open source tools for this particular case?
So I think there are a couple of reasons why you would do Watson instead of open source tools. One of them is expertise. A lot of companies, particularly not technology companies, right? Companies that are more focused, in this case, on financial services and having expertise in that area. They don't always know where to begin with the open source tools. They don't always feel like they have the data science expertise internally to create an open source solution that would do this. So I think that's one of the things that it's easy for me to forget, at least working in the Bay Area at a technology company, that a lot of major Fortune 100 companies really feel like they lack the data science expertise internally to embark on these kinds of projects. Another thing is that with Watson, IBM has invested a lot of time and energy into pre-training our models so that the customization is a lot faster and easier for our clients. Whereas if you're starting from scratch, building an open source model, from scratch, that's going to take a lot more compute time. It's going to take a lot more training data than if you're working on top of our models that we've already invested in.
If I could add an example
Yeah.
to that, speaking specifically about these financial services use cases, we actually acquired a company called Promontory, and they are people who are experts in regulatory compliance, right? So they didn't come in necessarily to be expert data scientists. They came in to advise and to train even those AI systems to understand regulatory compliance. So one of the things that we see across the industry, and you'll no doubt encounter in your field, is that people are discovering this value in expertise and data. And increasingly, if we're talking about open source tools or maybe some of the other tools out on the market, one of the challenges that you have is that you're not always getting to keep all your data in your system as privately as you would like. And so one of our big kind of strategic initiatives has been bringing the expertise in-house so that we can train those systems and not necessarily make all of those learnings something that reveals one of our clients' learnings to another, one of their competitors potentially.
Yeah.
So in other words, we could use AI to determine the tipping point of a politician to change the law in your favor.
Oh, interesting. What do you mean by tipping point? Well, should I repeat the questions for the live stream? Okay, let me repeat the question, 1 second.
Players and then know which way they're going and how much gift dollar needs to go.
An analysis of donorship. So the question,
So the application in 1992.
really?
Yes, which used AI. I didn't call it that.
That's really interesting.
It's the
Let's-
same idea.
Yeah, so
repeat the
repeating the
question
question quickly for the live stream, since they're relying on this mic that I don't think can pick up all of your wonderful voices. So the question is about using AI to understand the tipping point of a politician to make a law in your favor, particularly analyzing campaign finances, right? And
It's analyzing all the players at the table and which way they're going.
analyzing all the players on the table and which way they're going. That's a really interesting problem to solve, and it sounds like you solved it back in the day.
I don't want to take credit for that. That was part of an application.
Yeah. So that seems like a pretty standard sort of trade-off analysis, right? Where you're analyzing the trade-offs between different players at the table and trying to figure out.
When you first determine what's the tipping point, then you determine who's pushing which way, and then you decide which momentum.
Yeah. So that brings up a really interesting point, though.
Change the law and you fix the tax code and therefore you get the tax.
Yeah. That brings up a really interesting point that I think is reflected a little bit on some of the hopes and also some of the fear post-its that we saw, is that there are lots of interesting problems that we've thought up until now are very difficult to solve or very difficult to understand, that we have the potential to solve now that we have the ability to analyze this kind of unstructured data or lots of different types of data at scale. And some of those problems seem like they're going to be really great to solve, like the problem of figuring out how to get politicians to work more in your favor, right?
Well, these are they're competitive tools, so everybody has these tools and each one uses them in their favor. It becomes more interesting when they become a service bureau.
Yeah.
And then you collaboratively use it as a consortium or a service bureau.
Right. Well, and what if somebody that you disagree with is using the tool to get a politician to create?
So
Yeah, yeah. So that, I think we should add some of those questions of like, people being controlled and who has the access to these tools and the ability to harness their power. Did you have a question?
You showed a lot of case studies from your clients, and I was wondering to what extent it's useful or necessary that client managers also at least a basic understanding of AI.
Really good question. So for the live stream, the question was, to what extent is it necessary for clients to have a base understanding of AI as they're engaging in these types of projects? And I think that's one of the reasons why B and I have jobs. But also there are huge parts of IBM that are focused on this ability to work with a client while also training them up in some of the skill set areas they need to develop, like data science, like machine learning. So actually right here in Galvanize, there is an IBM office called the IBM Cloud Garage that's designed to work together with clients on an MVP product. A lot of them are working on AI stuff, Watson stuff, but they also might be working on more cloud-based applications generally. And the whole model of the garage is that you do a design thinking session to ideate together on what the MVP should be, and then you do pair programming for a period of sprints where an IBMer and somebody from the client are working together to build that application. So hopefully by the end of that MVP delivery, you have somebody from the client who has the knowledge they need to continue maintaining and potentially even adding to that application. So that's a really great point, and we definitely recognize that in order for clients to be successful, they not only need to understand the base technology, but they also need to understand where the technology is going so that they can continue building these applications and adding to them in the future. We don't want any of this stuff to be static, because we all know the data isn't static, the technology isn't static, the business needs aren't static. If you build an application that's totally inflexible and the client can't add any features to it down the road, they're probably going to stop using it. And in our SaaS-based economy, that doesn't work for our business model either. Cool, this is great, lots of engagement, I love it. Okay, so on the subject of recommend with confidence, and also on the subject of perhaps pushing some of our boundaries in terms of what we think of AI and what our hopes and fears are, I want to show you a demo. This is a demo application, so this is not actually something that we've gone to market to sell as a SaaS product. You couldn't go out to IBM's website and purchase this product. But this is a demo of some of our different Watson APIs, and it's a tool that we built called Client Insights for Wealth Management. So this is a tool that's designed to be an application used by wealth managers, and can you guys see that okay? In the back, is that big enough? Cool. So wealth managers who are dealing with a client list of incredibly high net worth individuals, think somebody working at BlackRock or Goldman Sachs, and they need to make really personal recommendations and have a personal relationship with many of their clients, but their client list could be, hundreds of people long. So how can they help their clients have a better experience and make their clients feel like they're having a really personal relationship with the wealth manager every single time they interact? And another thing that we're trying to do here on the subject of recommend with confidence is help the wealth manager make better recommendations and take better actions for each of their clients' really specific needs. So we're analyzing lots of different, both structured and unstructured data sources on the back end to deliver this dashboard to the wealth manager. And the first thing we'll see here, we have 20 top action clients. we've been able to predict, by analyzing all of those different data sources and using predictive analytics models that we've built in the back end, what actions various clients are going to take that are relevant to me, the wealth manager. So right away, I see that Alex Anderson is a client who has high client attrition predicted. He's predicted to leave my company. That's kind of the worst thing that one of my clients can do. So I'm going to want to do something to try to prevent this from happening, right? To prevent churn. So I click into Alex Anderson, and the first thing we'll see over here on the right as it loads is the factors that are going into this prediction of his attrition. So here, I'm just going to zoom in a little bit so you guys can see. We have an 85% likelihood predicted that he's going to churn from our company, and the factors are there's been a decrease in his login activity, decrease in his trading activity, and a decrease in his portfolio average return. Now, all of those are based on structured data sources, right, that we're pulling directly from this client's interaction with our website, with our products. Now, the next thing that's based on not structured data is the fact that we're suggesting to this wealth manager that the next best action for him to take is to call the client to discuss decreased portfolio returns. This is something that we're predicting based on what wealth managers at this company in the past have been able to do to prevent clients from leaving, to prevent clients with a similar profile from churning from the company. This is exactly what we're taking advantage of that unstructured notes section of the spreadsheet to get, right? We're looking at all of the things that wealth managers have said they've done in the past, and we found that calling the client to discuss the decreased portfolio returns has worked most effectively. Now, the next thing that we're doing, analyzing that unstructured data, we have this section called Relationship Coach. Relationship Coach leverages one of our APIs called Personality Insights, which is based on the field of psycholinguistics. Have you guys heard of psycholinguistics? Fascinating area of psychology. For those of you who don't know, it's the field of psychology that says that the words you use, your sentence structure, your grammar, all of that reflects your underlying personality. And if any of you have applied for a job in the government, they conducted a psycholinguistic analysis of you to figure out if you're likely to be a spy or somebody crazy off the rails. Yeah?
How do you detect sarcasm?
Sarcasm. That is a question that we get without fail. So Personality Insights is a model that we trained based on psycholinguistic analysis conducted by psychologists. So the training data that we used is essentially we had a bunch of annotated writing samples that psycholinguists, a whole group of psycholinguists, collectively analyzed, and then those output scores, we were analyzing against 52 personality traits and scoring each one of them based on that writing sample. All of that was our labeled data set. So this particular API is less about detecting sarcasm and more about detecting this pattern of sentence structures indicates a more cheerful person, or this pattern of words indicates a more adventurous person. We do have another API called Tone Analyzer that's focused on detecting emotional tone, and sarcasm is not currently one of the supported emotional tones, but we're working on research projects to sort that out. Of course, it's very culturally dependent and challenging.
There's a famous data set for those of you who want to work on the sarcasm problem, actually from Reddit, so very ripe with a lot of examples.
Super sarcastic.
So if you want to go into that space, it's an area that there's still a lot of work being done.
Yeah. But what this psycholinguistic analysis that we've done really quickly with this machine learning model, say that 5 times fast, what this allows us to do is to tell our wealth manager, based on our analysis of this client's emails back and forth with you, we understand that he has an 84% vulnerability score. He's easily overwhelmed in stressful situations. So you might want to approach him about his decreased portfolio returns gently. You know, don't stress him out. He's going to become overwhelmed. And this is really the core of that recommend with confidence. Analyzing unstructured data to understand somebody down to potentially the personality level, and then make recommendations for what should happen next. Love it. Lots of discussion and questions. Yeah, let's go with you.
For this particular use case, you're saying the data set, the email set back and forth. Were there really enough emails to get a 100% match? That seems...
That's a really good question. So for Personality Insights, we recommend that you analyze at least 1,200 words. So depending on how prolific Alex Anderson was as an emailer and how long his time has been with the company, you're right. You would, want to make sure that you're past that threshold to have a certain confidence level. But the other thing about these scores is that these scores are the match based on the sample size, and the more text-based data we analyze from Alex Anderson, these scores might change and become, slightly different with higher confidence. So this match percentage isn't a confidence score for our model detecting that emotional tone. It's more like a score out from 0 to 100 of how much this person fits that trait. So we might be detecting liberalism at 100% with 65% confidence. Does that make sense? You had a question in the back, I think.
Yeah. So, for example, if you have a person as manager, he can identify that you're possibly you have some personal issues, which is why your overall performance is going to downgrade, or possibly you could be sick.
Yeah.
How would this identify that?
So that's a really good question. From the HR side of things, how could you use a tool like this to potentially help a manager understand why somebody's performance is dipping? So that's actually another use case for personality insights, is helping to understand the relationship between an individual and a potential team, and having better matches with people within certain roles. Of course, there are legal implications with hiring, so we're not doing any of this on the front end with you can't hire that person because he has a high challenging authority score. But you are able to do this kind of personality analysis to understand how a certain individual might interface with a manager and try to find the best manager match. Now, it's going to be the same 52 personality traits. So it's not going to identify things like, this person had bronchitis for the last 6 months and so they were less productive. That would be a different kind of analysis where you need to look at, communications from that person, or maybe you just talk to the guy, right? You don't need to use technology for everything. Yeah, so that brings up another really good point. Misinformation, the question was about, and could this bring up potential misinformation? So another thing that I really want to make sure is clear is that every single one of these data points that we're bringing in, these unstructured data points, needs to be taken as part of the full context of what you're looking at, right? We're not trying to say that you should make every single decision now based on somebody's personality insights analysis. Personality insights is one more tool in our very large toolbox, and generally AI is one more tool in our very large toolbox that allows us to bring in new data sources that potentially can uncover new relationships or new correlations that are valuable. You had a question as well, I think.
Yeah, when there's better insight and understanding, does that become manipulation?
Manipulation. Yeah, that's a really great ethical question. That's an ethical quandary that, I don't necessarily have a good black or white answer to. I think that's one of the big challenges of this technology, is when we're able to get such a granular level of understanding about a person or a thing or a situation, what do we do with that information, and what is our moral obligation to use that information for good or evil? Or it's a big challenge, you guys. We live in a tough world. Okay, I do want to make sure that we have time to go through all of the examples, so maybe I'll take one more question about this section. Yeah, you in the back?
How are you testing to ensure that this is accurate? For example, in healthcare, very difficult for computer software to interpret depression. Depression on someone's skull physically, or the word bed is often used in somebody describing depression. Software can just interpret that as a word hole.
Yes. Yes.
Or elevation is when a patient moves the eyes not in depression is when a patient moves their eyes.
Yeah.
Very accurate in terms of depression. It almost sounds like determining anxiety. It's almost kind of like a psychologist listening
Right.
to a patient. But how do you know that it's accurate in healthcare if it hasn't been very accurate at all?
Yeah, so the question is around accuracy. How do we ensure that these models are accurate when different words can mean such drastically different things, like depression meaning a hole in your head, or even a hole in the ground outside of the context of healthcare, or depression, the mental health challenge. So one of the things that we try to make really clear to clients when we're telling them about Watson is that we at IBM are not creating one model for everything. Because at the moment, the way the technology stands, that will not work. We have not figured out the general artificial intelligence that can answer a question just as accurately as it can about oncology, as it can about mining resources in the ground. So the way that we approach creating solutions and applications for our clients is that we have very specific models trained for solving specific problems with our client. So to answer the question about ambiguity between different terms, the first thing you'd want to do is make sure that the model you've trained understands that when you, a psychologist, talk about depression, it should have higher confidence that you're talking about the most relevant type of depression to you. And then it should also start to understand the context in which those phrases are occurring. So if you say depression in somebody's head, okay, that might still be ambiguous. If you say there's a depression in my front yard, that's pretty clear that you're not talking about depression, the mental state, right? So there's a couple different things that we do. We create these custom models that are really tailored for each specific use case. And then we make sure that we have taught some context awareness to our language models so that they're not only looking at what the individual word is, but they're looking at the context in which that word is occurring to have greater confidence in a particular meaning.
But maybe you could also talk about how we study the concordance between doctors and systems?
Yeah, so that's another, in the very specific field of healthcare, we're constantly doing concordance studies to test how our healthcare solutions, we have a couple of solutions, particularly Watson for oncology, Watson for genomics, Watson for clinical trial matching, that make recommendations for certain patient treatment options based on health records. And we conduct concordance studies where we have a board of doctors review past cases, and we feed those cases also into our Watson system. So Watson is making a retroactive recommendation, basically, and we see if the board of expert doctors agrees with the retroactive recommendation that the Watson system has made. And it varies by type of cancer for our Watson for oncology solutions, but our concordance rates are generally between 96 and 98%. And there was actually, at the very beginning of Watson for oncology, there was a study we did with a hospital in St. Louis where they had their tumor board go in and review a whole bunch of tumors. And for 30% of the cases, Watson actually found some potential different treatment options that the doctors had missed, that the doctors upon review agreed were worth looking into. So not only are we achieving relatively high levels of concordance with how our solutions are performing, but potentially we're even identifying things that the doctors had missed in the first place.
And it's worth noting too that there are some areas where we're not there yet.
Yep.
That's why this is such an exciting field to be in. So what we want to do is give you the kind of language to be able to conduct those conversations in a business space, in a healthcare space, if you're in a public service space, trying to understand what is the root use case here? What are the different, and I've actually clustered some of the hopes and fears that you've had over here. What are the root issues that we're trying to address? And then that gives you a strategy on how you're going to actually apply technology to address those problems. So it's definitely not a fully solved space,
Yeah.
and that's why it's so exciting.
Okay, I'm very wary of time. We have a lot to get through, you guys, but it's been a really good conversation. So let me move on to the next workflow and we can keep it going. Enrich interactions. How many of you have interacted with a chatbot? Everybody raise your hands. You've all interacted with a chatbot. I can guarantee it. Personally, I hate the word chatbot because these systems are so much more complex than just chatting. They can do so much more than just have a chatty little conversation. We've seen AI systems built that can actually make proactive outreach to people to get them to take certain actions, like helping diabetics better understand how to regulate their diet. We've seen systems that can help guide people down different decision paths by providing the right information. The whole point of enrich your interactions is how can we use AI systems to create more conversational computing systems that allow us to interact with them more naturally and in potentially more engaging ways. Clicker. So 64% of consumers expect real-time responses at any time. No company has the bandwidth, the payroll, the resources to provide 24/7 real human being customer support. So we're helping to close that gap between consumers' expectations and what companies actually can afford to and are able to provide with AI systems. 62% of customers will consider switching to a competitor after only 1 to 2 bad experiences. So the threshold for failure here is incredibly low. We need to have systems that can deliver very good experiences every single time. And we have tons of clients who are using AI technology to create these kinds of conversational interactive systems. Watson Assistant, which is our primary conversational API, is actually our most popular API on the Watson stack. Lots of people are using it. There's tons of great documentation online if you guys are interested in playing around with this. I recently built a little chatbot that could answer people's online questions about me, Susannah Shattuck, like, where'd you go to school? What do you do for work? And it was super easy. So highly recommend playing around with this stuff. From the case study perspective, Bradesco is one of the largest banks in Brazil, and they faced this challenge where their customers were having really long wait times, both online when they were contacting customer support and at a branch in the bank to get answers to their questions. So Bradesco wanted to see if they could use an AI system internally to reduce that wait time. So they actually created a tool designed for Bradesco employees to be able to go in and input questions that customers asked them face-to-face or over the phone, and the AI system would surface the most relevant answers from the pages and pages and pages of Bradesco documentation. Now, that was so successful that they actually decided, you know what? We're going to keep this for the employees, but we're also going to roll it out for our customer-facing website. We're going to have something online that customers can actually talk to get these answers. And they were able to achieve customer satisfaction levels of higher than 85% with this AI system that customers were interacting with. So this is a great case study. Again, we have more information online that I'm happy to send you afterwards if you want to learn more. But this is just one of the many IBM clients using Watson technology to create these conversational systems to solve business problems. Questions? This is maybe an easier one to swallow than the last one. Yeah?
Do you have IBM Red books that are out for Watson?
What's that?
IBM Red books?
IBM Red books. Yes, we do actually. There are a number of resources, and I think the last slide of our presentation has some links with a number of those different resources, including code patterns, but we do definitely have Red books as well. Cool. I'm actually going to skip this demo because it's just a chatbot, but we can send out the link afterwards. The North Face created a retail decision support chatbot where you can go in and talk to the system about what your needs are to find the right coat. And if you've ever bought a coat from the North Face, you know that they have 10 million different factors that go into finding the perfect coat. So it asks you in a conversational way, and it's very useful. All right, detect liabilities and mitigate risk. I was actually very excited to read the post-its up on the board around hopes for helping decision makers avoid problems and predict potential issues. This is a huge area of focus for AI. This is really all about harnessing the power of, again, that structured data in combination with unstructured data to understand problems before they occur. And when we're talking about liabilities and risk, a lot of this comes in the form of legal obligations, contracts, regulations, right? How can we help business professionals understand the mire of these very complex documents and quickly understand what are their obligations, what are they required to do in order to avoid getting trapped in a bad situation? And some examples, 62% of firms are expecting regulators to publish even more regulatory information in the coming year, and 22% expect significantly more. How many of you have had to deal with GDPR in the last few months in your company? Yeah, so you know firsthand that regulation can really throw a wrench. Yeah?
To what extent do regulations have to be, or meet certain criteria to be usable for these kind of?
Good question, and that's actually a really good segue into my next demo.
It's like you're a plant.
Yeah, it's amazing. Wrong way?
It switched sides,
Okay,
sorry.
no worries.
It does.
So, Compare and Comply is a relatively new Watson service that we created based on one of our APIs called Watson Discovery, Watson Discovery allows you to load a huge volume of documents into a system. The system will annotate those documents with metadata that you've trained it to understand are relevant and important to you, and then you can query that metadata in natural language. So Compare and Comply is a pre-trained discovery-based system that annotates contract-type documents with information about the different clauses within that contract. So then you can really quickly perform a check. Here are 2 contracts. Do the buyer obligation terms match? So this is a demo of this, and once again, I'm going to zoom in a little bit for you in the back. So we have 2 different types of contracts that we can analyze in this demo, and this is publicly accessible, so you'll receive links afterwards. I'm actually going to pick the statement of work. And this is the original contract. You can see it's long, it's full of all kinds of legal jargon, but I really want to quickly understand what are my rights as a buyer here. So these are the categories of clauses that we've trained the system to identify. And so now I can go in and say, show me all of my buyer's rights in this document. And it really quickly highlights the phrases that fit that particular type. So I can scroll through and I can see all of those areas. Now this is the first step, right? This ability just to identify different types of clauses based on language. The next step would be to then go in and actually make a comparison to say, show me places where these 2 buyers' rights in these 2 contracts don't match, where they don't line up. Or show me the place in this legal regulation where my company contract actually might be at odds. And it's that power that allows us to suddenly bring understanding to this crazy world of legal obligation. And to answer your question, these types of documents, so we're able to pre-train the system to understand the basic core language of these different types of clauses. We're currently focusing on more of the like procurement contract, supplier relationship type contract, but there's no reason why you wouldn't be able to do that training on government regulation, and that's something that if you personally are interested in, I know our Compare and Comply team is working on getting some beta testers for their new models.
I can imagine that the challenge is also that in a lot of these regulations, but also laws, there's gazillion references to other regulations and other laws.
Yeah, exactly. So that was something that we also had to deal with the H&R Block example, the tax code. And so one of the things that we would want to do in that scenario is also probably make a fairly custom model for a certain type of regulation so that we manage the scope of all of the input documents that you need to have in that corpus, in that body of data that you're then querying to come up with answers.
I also wanted to shout out one other cool thing about this particular example, which is that we realized in doing these applications that the world of information that exists out there doesn't oftentimes come in the most beautiful machine readable format. And so tools like this actually pull in from PDFs, and we've been doing a lot of research in how we can actually use, for instance, the ability to pull diagrams out of PDFs and perform analysis on those. So there's a lot of really interesting work still yet to be done, and that's kind of this cutting edge stuff in terms of taking the information as it exists out in the world and teaching the AI how to interpret that information so that we don't have to change it to fit into what a computer wants it to be.
Yeah, really good point. All right, on a very similar note, anticipate and preempt disruption. Just like detect and mitigate liability and risk, anticipate and preempt disruption is about understanding problems before they arise. And this is a particular area where we're really interested in pulling in things like IoT sensor data, that temperature type data, weather data, structured data, and then marrying that with the unstructured analysis to really deeply understand potential problems and ultimately recommend good solutions. So again, a few stats, 500,000 Americans could not get sick every year if we reduce foodborne illness by just 1%. So how can we prevent disruption in the food supply chain? This is where we're not only using AI technology, but we're also marrying technology like blockchain to track the provenance of different products throughout the supply chain and really understand where they're coming from and where they're going and hopefully prevent that kind of issue. The example that I have for our anticipate and preempt disruption is around Kone elevators. So Kone is a company that creates the vast majority of elevators in the world, and they had this challenge where they wanted to figure out if there was anything they could do with predictive maintenance to prevent elevators from breaking before they were broken. So they actually have IoT sensors in a huge number of their elevators. And based on all of that IoT data that was coming in, they were able to create predictive models such that when we start to see certain values coming out of that IoT sensor data that fall outside of the general thresholds, we can understand and we can predict what type of problem is most likely to occur with that elevator in the next period of time. Now, one step further, we can use that sensor data to actually proactively create a work order for a field technician who's going to go out and fix that problem. And we can provide that field technician based on, again, these predictive models and based on all of the unstructured documentation that Kone has about their elevators with recommendations for what tools they should bring with them, how much time they can expect working on this problem, what's the best action that they should take when they arrive at the elevator. All of that prediction and coming up with that work order in advance for the technician relies on this ability to analyze that data and create models that can understand what's most likely to occur. And all of that is based, again, on this marrying of structured and unstructured data. Any questions here? Crystal clear, I love it. All right, scale expertise and learning. This is the last one. So how many of you have had this challenge where you were about to leave an old job to move on to a new one, and suddenly on your last day you sit down with your boss and they're like, okay, tell me everything you know. And you say, that's going to take a while. This is a real problem where people have expertise that they've gained through years, potentially decades of working in a role, and when they retire or they move on, tons of that knowledge gets lost. This is a huge problem, particularly in Japan, where they have an increasingly aging workforce, and they don't have as many young people coming into these new roles. So they not only have to figure out how to scale expertise and learning, but they have to figure out how to make the one junior guy have all of the knowledge of the 10 senior guys who just retired. We have lots of Japanese clients coming to us trying to solve this problem. It's massive. So again, a few stats, about 10,000 baby boomers are retiring every day, and they're taking all that knowledge with them. So one of my favorite client examples of all of these is the example we have with Woodside Oil and Gas, where they have this very complex, they're an Australian oil and gas company, they have a very complex set of assets of offshore oil rigs that need to be maintained and constructed and worked every single day. And they faced this challenge where they found that their engineers were spending a lot of time trying to just find answers to questions about how to solve certain problems. Because a lot of the engineers who were working on these rigs had not been present when the rig was first built, when it was first brought online. They weren't familiar with all of the intricacies that the people who started that project knew very well. And so they needed to find a way to take all of that tribal knowledge, all of that organizational knowledge, and actually make it accessible to a new engineer coming and starting the job on the first day. So they created with us a Watson system that again is based on that discovery API that I mentioned before, this ability to query with natural language a huge volume of documents. And they actually were able to take about 30,000 documents and feed it into the system. And they found that it reduced the amount of time that engineers spent searching for answers by about 75%. So they felt like there were some real winning numbers coming out of this project. And ultimately they were able to feel like they could give their junior engineers a task and they'd be able to find the answers just as quickly as somebody who'd started the project on day one. So any questions about this? All right. So the last thing that I want to leave with you before B and I come back together to close out, and I think we have time for a couple more questions. Any of the things that I showed you today are accessible and discoverable on this public page, Watson Products and Services. This is where we list out all of our core APIs and services under the Watson platform. And if you click into any of these, you'll find demos, you'll find GitHub repositories, starter applications, all kinds of resources if you want to play around here. And remember that sliding scale that I was talking about. At the API end, where you're building your own applications and you're paying fractions of a cent per API call, we actually have tons of great resources for startups that are interested in playing around with some of these products. We have a program called the Global Entrepreneurs Program where you can get a whole bunch of free credits to play around with these APIs and potentially build them into your product as a startup. So lots of cool opportunities here. I highly recommend visiting this page when we leave. And with that, thank you. Questions?